Hello dear students, we continue with the exam pack. Question number 5. Here you can see the spectrum that is that shows the spectrum of an object. Okay, and these lines, these dips are actually the absorption lines. These are the absorption lines, the rays that are being absorbed. Okay, so explain which row of the table correctly identifies the most likely the source of spectrum and the feature labels as Y. Okay, so the source of spectrum is star, discharge tube, star, and discharge tube, and absorption lines. So clearly these dips are actually the absorption lines. So these dips are the absorption lines. So option emission line C and D is the wrong option. So A and B, we have to choose A and B, whether A is option or the B is option. Now we discuss in detail what is absorption line and what is emission line. Okay, so actually, for example, here we have a complete description. For example, if we have a continuous light source, this is the continuous light source, and light is emitted, and this source emits all the radiations in all the directions. Okay, so if we draw the spectrum of this, so it shows the all continuous spectrum. So continuous spectrum is that shows the all possible wavelengths, so that the continuous spectrum shows all the color from red toward this end, and the blue and the other colors are on the left side. Okay, so if we draw the graphs, we see that there is a continuous brightness, there is a continuous spectrum. This shows the continuous spectrum here, this kind of spectrum. Okay, now suppose that when this light, these all the colors that are flowing, that are moving, that passes through the cloud of gas, and when they passes through the cloud of gas, so we know that the some wavelengths being absorbed by the atoms in the cloud, some rays being absorbed by the atoms in the cloud. So these lines absorb, and when they absorb, so as we know that when light is absorbed by the atom, so the atom is excited. Atom being excited means the electrons are excited. So when the atom excited and it de-excite, and when it de-excite, due to de-excitation, it emits certain wavelengths, it emits certain light, certain colors. So these colors are actually shown by the on the graph or on the spectrum. The spectrum shows on the certain, just like yellow color, blue color, only certain wavelengths, just 1 2 3 4 5 wavelengths. It shows 5 wavelengths, and the corresponding wavelengths, there is a graph between wavelength and brightness. So you can see that there is a peak. This is the emission spectrum. For the emission spectrum, we have this kind of peak only. Okay, so some lines are being absorbed by the cloud, and some lines are being passed through that. Some lines being passed through that mean that they are transmitted through that, and the transmitted light is we have a detector, and we detect them, and we draw the absorption spectrum. So the transmitted light shows this blue, black, this red color, yellow color, blue color, and all these are actually the transmitted light that we receive on the detector. But some colors are missing. The black, here you can see that this is the missing colors. These missing colors are actually the absorption spectrum, that the light is being absorbed by the cloud. So these are colors that are being absorbed by the cloud. So that's why they are missing from the spectrums. These colors are being missing. You can see that this color, yellow color, is shown on this emission line. You can see that. So it means this color is missing. So on the earth, on the ground, on the where we receive this light, so we can see only the missing color. These colors are actually the absorption lines, and these missing color is also missing from the continuous spectrum. So when they are missing, so we have a dip. We have a dip in the continuous spectrum. So just like in this continuous spectrum, we have dip, just like the dip. So this is missing spectrum. So it means if there is a dip, so this dip is shown by the absorption spectrum. So our correct option is the absorption spectrum, not the emission spectrum, because discharge tube also shows certain wavelengths only, that the graph is on the peaks, not the dips. So discharge tube shows the emission peaks, that are the peaks. So this option B is also wrong. So the star, it shows the absorption line because there is a dip. So dip shows always the absorption peak. So the A option is the correct option is A. Here the answer will be the star and the absorption line. Okay, thank you.